Hello everyone. Welcome to the fourth lecture series on IoT components. In this lecture, we will continue our exploration of the essential components that make up the Internet of Things ecosystem. As a quick recap, IoT refers to the network of physical devices, vehicles, home appliances, and other objects embedded with sensors, software, and connectivity, enabling them to collect and exchange data. So in the previous lectures, we covered the following components, that is about the sensors and the actuators, which are the physical components responsible for capturing the data from the surrounding environment, which acts as a sensor, and performing actions, that is actuator, based on that data. So now let's dive into the next set of components. So the first important concept is functional components of IoT. So when we talk about the functional components of Internet of Things, that is things, we are specifically referring to individual things. So first comes the things, which is specifically referring to the individual devices or objects that are part of the Internet of Things ecosystem. Here, these components enable these devices to interact with their surrounding, communicate with other devices or systems, and provide data and functionality. So next comes the local network, which is often referred to as a local area network, LAN. It is a network of interconnected devices within a limited geographic area, such as home, office, school, or small business. So the primary purpose of this local network is to facilitate communication and data sharing among the connected devices, making it easier for users to access resources and collaborate efficiently. So the next comes is the major component is internet. So in short, for internet, we call it as interconnected network, which is a global system of interconnected computer networks that use the Internet Protocol suite, that is TCP and IP, to communicate and share resources. It is a vast network infrastructure that connects millions of devices worldwide, including computers, servers, routers, switches, smartphones, and other smart devices. And the next one is the backend services. So this is also known as server-side services or backend systems. And these are the components of a software application that runs on a servers and handle tasks behind the scenes, which is away from the user interface. So these play a crucial role in processing data, managing the databases, handling business logics, enabling communication between various components of a software application. And they say in general, we can say that these backend services serve as the backbone of web applications, mobile applications, and other software systems, which provides the necessary functionality to support the front-end user experience. So the last part is the communication, which is the important component of IoT. It is a fundamental aspect that enables the devices, or devices, sensors, and systems to interact or share the data and collaborate to perform various tasks and achieve specific objectives. So this IoT devices need to communicate efficiently and securely to make real-time decisions, where it has to collect the data and respond to changes in the environment. So this is called as a fundamental or the basic functional components of IoT. So next comes the implementation of IoT. So let us see what is the implementation of Internet of Things. So one end, we have various devices which include processor, sensors, and some fitted equipments like radios, etc., which senses the data. They can also be called as IoT nodes. These devices can talk to each other, but they are under the jurisdiction of a gateway. This gateway takes off the address of the devices in that particular local area network. From the gateway, the sensor passes the data through a proxy server to reach the internet. So from the through the gateway only, the sensor passes the data to the proxy server using the internet. Then the data passes through a web socket, and from the web socket the data moves to the cloud server, and it is the cloud server backend processing and analytics takes place. Based on the analytics and interferences, the actuation takes place on the sensed data. And actuation, for example, it may be lighting a lamp or turning off a motor or fan or etc. So this is how the implementation of IoT works. This is a simple example of IoT implementation. So next is, what is IoT interdependencies? So IoT is Internet of Things implementations involve various interdependencies between different components and stakeholders, and these interdependencies are crucial for the successful functioning of IoT systems and applications. So there are, you can see in the figure, there are various interdependencies which is taking over, where several interdependencies are involved in the implementation of IoT. In between the sensors and actuators, we have lot of technologies which are interdependent. The sensors sense the data, and sensed data will be satisfying the application requirements. Okay, so we need an operating system which is the real-time kernel, and power management, which performs the duty of the cycling of the sensor. So this determines how much time the sensor will be in active state, how much time it will be in a sleep state, how to power the sensors, how much power will be consumed, whether it can be optimized, and so on. This all will be taken care by this. So there are various radios like 6-LoWPAN. As you could see here, these are the various radios. 6-LoWPAN, and then Bluetooth, and Zigbee, Wi-Fi, Ethernet, and finally we have LoRa Wi-Fi, which are the connectivity terminologies that help to communicate the sensed data, whatever it is sensed here, connectivity towards the sensed data to other nodes. So we also have a virtual machines which takes care of the virtualization of the nodes. So there are different application level protocols like HTTP client, MQTT client, and COAP client, which help for functioning of Internet of Things. All these together constitute the horizontal embedded devices. So these are the IoT interdependencies. So next what we have is service-oriented architecture. So here we have 4 layers, namely sensing layer, network layer, service layer, and the final one is the interface layer. So the diagrammatical representation of service-oriented architecture has been depicted here. In the bottommost layer, here what we have is the sensing layer, whose prime responsibility is data sensing or taking care of the acquiring protocols. So various sensing devices like RFID tags, intelligent sensors, RFID readers, Bluetooth devices, and wireless sensor networks, etc., constitute the sensing layer. The network layer, above the sensing layer is the network layer, where here we have the sensing layer which comprises of wireless sensor networks, internet, mobile networks, database, social networks, and wireless LANs and everything. So above this we have service layer, which comprises of the business logic, service repository, and then service integration, and this all comprises to service repository, and the service division and service integration. So the next comes is the interface layer. In the interface layer, we have this is the application front end contract. So this is called as an API or interface forms, the topmost layer. So this is also called as an interface layer. It has a security is a matter of concern in all layers from top to bottom. So this is the overall infrastructure of a service oriented architecture. So next what we have is IoT challenges. As of now, we have come to know what are the services that can be acquired by Internet of Things, and there are also some of the challenges that has to be faced when it comes to developing IoT devices inside a laboratory or network connectivity. It will become it is not a major issue with the only few devices backed up by a server. Connectivity has very low latency and it is seamless. But deploying the same IoT application on a global scale with thousands or maybe even millions of users accessing it simultaneously, it is completely different. So the internet isn't only one network, and there are many considerations like cell towers, connectivity, firewalls, proxy servers that can cause problems with the connectivity. So there are a few challenges that has been discussed here, and the first one is security. So this acts as a crucial issue on the internet, probably the most significant challenge for the Internet of Things. So when we increase the number of connected devices, obviously the number of opportunities to exploit the vulnerabilities through poorly designed devices can expose users' data to theft, especially when the data streams are left with inadequate protection. So in certain cases, this may even harm the safety and health of people. So for this security, data encryption is the only method of providing security towards IoT. And IoT collects tons of data, and this data retrieval and processing is the integral part of the whole IoT environment. So most of the data is personal and need to be protected through some encryption. To address this IoT security issues, we use a secure socket layer protocol, which is called as SSL protocol, wherever our data is present online. So websites already use SSL certification to encrypt and protect the user's data online. So this is only half part of the equation, and the other half is to protect the wireless protocol side, where data is being transferred wirelessly. It needs encryption as well. So data authentication is another method. The first method is data encryption, and the second method that we use for security is data authentication. So in data authentication, using this also we provide security in the IoT environment. After successful encryption of data, the devices itself being hacked still exist. So if there is no way to establish the authenticity of the data being communicated to and from IoT devices, security is compromised. For instance, when we wanted to build a temperature sensor for smart homes, even though we encrypt the data it transfers, there are no way to authenticate the source of data, and then anyone can make up fake data and send it to your sensor, instructing it to cool the room, even when it's freezing or vice versa. So authentication issues may not be upfront, but they definitely pose a security risk. And the third thing that we have is side channel attack, which is another security issue in IoT. So here the encryption and authentication both are in place. Still, it leaves scope for side channel attacks. So such attacks focuses less on the information and more on how that information is being presented. For example, if someone is accessing the data like timing information or power consumption or electromagnetic leak, in such cases, the information can be used for side channel attacks. This is the third major security issue. And then we also have hardware security issue, which has been faced by IoT. With all the hype and sudden interest in IoT devices, chip makers like ARM and Intel are reinforcing their processors for more security with every new generation. But the realistic scenario is it doesn't seem to ever close that security gap. So the problem is with the modern architecture of the chips made specifically for this IoT devices, where the prices will go up, making them more expensive. So affordable wearable IoT devices won't use such chips, meaning there is need for better approach. So these are the challenges. I mean, these are the major crucial issues that we face as a challenge for the IoT. So under security, we have the first one is data encryption, which is the only method of providing data security in IoT. And the second one is data authentication. And the third is side channel attack. And the final one is hardware security. So next very biggest challenge is scalability. With the exponential growth, the ability to manage efficiently all these devices is absolutely very difficult. So it will be like climbing the paramount. So our business needs to be able to monitor the operations of its services and add to its system as device functionality. So when deploying an IoT system, we have to keep in mind both current and future needs. If a system is not scalable, then it will not be able to accommodate the future expansion when it shifts to some other technologies. So this leaves business with unusable systems and devices that may either be replaceable or augmented, or both are expensive prospects. For example, 2G technology is still being used in more than half of the world's mobile connections, unless the companies still utilizing this technology are prepared for the network's impending sunset. They'll be likely find themselves with millions of useless devices on their hands in the not so distant future. So maybe it makes sure our plans incorporate long-term support for device based on technology projections in IoT. So next comes is energy efficiency. So this is another challenge of IoT devices. So energy efficiency, it has to take care of how it is going to work about or how it is going to give face these challenges when it comes to Internet of Things. So these challenges plays a major role where sometimes this energy efficiency has to give the knowledge that we could efficiently track and count the resources. So in some cases, this energy efficiency is very important where this IoT is connected with multiple devices, and the energy utilized here for the multiple devices has to be tracked, and it has to be put in forth in a proper way. Otherwise, this will become a very hectic drawback too. So that is the major challenge, another major challenge that we have. And the next one is bandwidth management. So bandwidth management is the number of devices that is connected. So when number of devices is connected with the IoT, obviously the network is skyrocketing. So this is going to be a massive change in the internet. So if you have more IoT devices trying to report data over low bandwidth link, then it is capable of carrying them to ensure that the most important data gets through, and we are going to filter out the less important data so that we can compress the remaining data down. So the problem going forward with IoT is every solution is going to be different and require different approaches to solve the network latency and bandwidth problems, and therefore it is difficult to make sweeping solution statements actually. So the next major challenge is modeling and analysis. So how we are going to analyze, make the analysis of Internet of Things. The data is quickly becoming a mainstream activity. So with many data sources, it is often an quick or quite effort, quite an effort to gather the source data required for analysis. So here it is necessary to identify what information is available, how it is formatted, and also to reconcile the data from different sources that often contained similar information. So another challenge is to determine the proper frequency of sensor readings. For example, when we consider a temperature sensor, this may spit out a reading every millisecond. However, in most cases, receiving that data at that cadence is overkill. That overkill has a price due to the cost of storing the extra data and the cost and complexity of analyzing the masses of the data that aren't valuable. As a result, it is necessary to determine what cadence actually has value for the problem you're tackling. So, if you're monitoring a car engine, readings once per second might be more than enough. So, the point is that we have to assess each metric and determine what you need through some experiments. So, filtering out the data down to the proper level or making the data into a meaningful pattern will be that much harder to identify. And the next that we have is the interface. So this is also another great challenge. So when it comes to interface, interface is nothing but it is an API where a person has to interact with the what is that, Internet of Things. So here it not only have the challenges of communicating with the people or having an API which can communicate with the people, but rather it also faces challenges like when it is getting interfaced with some other persons. It should also have that lack of documented or standards or the best practices that it is following. This is just like a privacy. There are a number of legal and regulatory questions that surround the Internet of Things. So next one is interoperability. At the most basic level, the Internet of Things is connectivity among people. So process and things. While this is a vast when spanning all industries, different devices, there are major issues that has been faced in Internet of Things, which is the enablement of interoperability between each connections. Different devices or equipments that um, made by some manufacturer cannot be integrated, or sometimes what happens is different operating systems cannot run on the same operating system, and sometimes different versions or times of purchase devices that weren't be used in the same time, and sometimes different incommunicable types of connectors or connectivity frameworks. That is also is a problem, and different or inconsistent communication protocol standards. It has to follow certain rules, and lack of programs that is needed to conduct the devices. This all is termed as an interoperability. And the final one is the data storage. Here the Internet of Things will have a huge impact on storage, where the volume of data, the radically different types of data are created, and it has to be stored somewhere, and storage is particularly needed. So machine generated data comes in two distinct types, creating two entirely different challenges. First, there is a large file data such as images or videos that has been captured by the smartphones and other devices, and this data type is typically accessed sequentially. The second data type is very small, for example, log file data, which is captured by the sensors. These sensors, while they are small in size, can create billions of files that must be accessed randomly. So there can be no single method to deal with the data generated by things, not least because there is such a wide variety of data generators and data types. For those planning storage for an IoT project, the first task is to determine the type of data the project will generate. It is also clear that data volumes are large and growing, that the data center needs to adapt to deal with them. And cloud-based storage may be only solution and nothing else. Then we have is the data analytics. So data analytics, as it has been discussed earlier, this is another challenge to identify complex patterns over time. The heart of many IoT analytics need to identify complex patterns or trends that occur over time. So what happens here is, when analyzing IoT data, in contrast, we often interested in deviations from normal rather than projecting the expected. So after identifying what is normal, we must work on to find abnormal patterns that are of importance. So however, there are multiple ways that abnormal patterns might evolve. Sudden increases in temperature would naturally draw interest. So that is how the data will get analyzed here. And there is much complexity in the identification of these time-based patterns too. So the final one is the complexity management. Complexity is as how difficult it is we are going to use it here. So here, this also needs some thoughtful considerations where legal issues concerned to Internet of Things devices, and which are limited to potential violences or civil rights because of law enforcement surveillances. In such cases, the very complex problems has to be managed in this. What is that? That also has to be a greater has to play a greater role in balancing this Internet of Things challenges. So also this technology is advancing much more faster pace than regulatory policies, and this IoT guidelines cannot keep up with the pace of the technologies. So what happens is, the methods or the interfaces or the configuration tools or the thoughtful designs, which is very essential for the future. And that is the only thing which can solve the problems, complex problems, or break down the complex problems, and it could be managed. So these are the IoT challenges. Thank you.